Welcome to this advanced Kubernetes tutorial on the API Aggregation Layer. In this video, we'll explore how to extend the Kubernetes API server beyond its core functionality. The aggregation layer is a powerful mechanism that allows you to add custom API groups and resources to your cluster, giving you full control over how Kubernetes behaves and what capabilities it offers. API aggregation is a mechanism that allows custom API servers to be registered and integrated with the main Kubernetes API server. Think of it as a way to plug in your own APIs into Kubernetes without modifying the core system. The aggregation layer acts as a proxy, intelligently routing incoming requests to the appropriate API server, whether that's the core Kubernetes API or your custom extension. This enables you to extend Kubernetes with new API groups and resources that go far beyond what custom resource definitions can offer. Let's compare API aggregation with custom resource definitions, or CRDs. CRDs are simpler to implement and store their data directly in etc., Kubernetes default database. They work well for declarative resources but have limited validation logic. On the other hand, API aggregation gives you full control over API behavior. You can use custom storage backends instead of etc., implement complex business logic, and benefit from advanced versioning support. While CRDs are great for simple use cases, aggregation is the way to go when you need maximum flexibility and control. Here's how the request flow works with API aggregation. First, a client, such as Kubectl or any API client, sends a request to the Kubernetes API server. The aggregation layer then examines the request and routes it to the appropriate API server based on the API group and version. Finally, the extension server processes the request according to your custom business logic and returns the response back through the aggregation layer to the client. This seamless routing makes your custom APIs appear as if they're native parts of Kubernetes. There are three key components in the API aggregation architecture. First is the API service resource, which registers external API servers with the aggregation layer and tells Kubernetes which API groups your extension handles. Second is the extension API server itself, which is your custom server implementing additional API groups and resources with your specific logic. Third is the Kube aggregator, which is built directly into the Kube API server and handles all request routing and API discovery. These three components work together to seamlessly extend Kubernetes capabilities. Let's look at a practical example of an API service definition. This YAML defines an API service for the metrics server. The API version is APIService.K8s.io/v1, and the kind is a APIService. The metadata name follows a specific format, version.group, which in this case is v1beta1.metrics.k8s.io. The spec section defines which Kubernetes service will handle these requests. Here it points to the metrics server service in the Kube system namespace. The group is metrics.k8s.io, and the version is v1beta1. Finally, the group priority minimum and version priority are both set to 100, which determines the order of preference when multiple versions exist. To use API aggregation, you need to meet several configuration requirements. First, you must enable the aggregation layer flags on the Kube API server. This is typically enabled by default in modern Kubernetes clusters. Second, you need to configure CA certificates for secure communication between the main API server and your extension server. Third, your extension API server must expose an HTTPS endpoint, not plain HTTP. Finally, you must implement proper authentication and authorization mechanisms to ensure secure access to your custom APIs. These security measures are critical for production deployments. Let's explore some common use cases for API aggregation. The metrics server is probably the most well-known example. It provides the resource metrics API used for auto-scaling and monitoring, serving endpoints like Kubectl Top. The service catalog is another popular use case, allowing you to manage external services through the Kubernetes API custom storage solutions are also common, where you need APIs backed by databases other than etc. for performance or compliance reasons. Finally, multi-cluster management platforms use aggregation to aggregate API is across multiple Kubernetes clusters, providing a unified control plane. These examples show the power and flexibility that API aggregation brings to Kubernetes.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.